Now we're about to practice evaluating functions. So there are many real-world functional relationships that can be represented by equations, and we will practice some of those in upcoming examples and assignments. So far, we've mostly dealt with functions that represent x and y, like this example, y equals negative 3x plus 1. Below is the same equation written in function notation. F of x equals negative 3x plus 1. All that happened there was f of x replaces y. And yes, we read it as f of x. So remember, f of x just equals y. F of x is the same as y. So let's go ahead and try an example below. Given the functions f of x equals x plus 1 and g of x equals negative x squared, find the following. So we're trying to find y values when we're finding f of something. So we know y equals f of 3. And that's just going to be our function with 3 plugged in. So y equals f of 3, which equals 4. And we can look at this as a coordinate as 3 comma 4, where x was 3 and our y value is 4. But the overall answer is f of 3 equals 4. Now we're going to do the same thing with g of negative 3. So sometimes we use different letters than f. So y equals g of negative 3, and that's going to equal negative 3 squared. So if we follow PEMDAS, we're going to square before we multiply by that negative. So we have y equals g of negative 3, which is going to be negative 9. So that is our evaluation of g of negative 3. And we could look at that as a coordinate as we plugged in negative 3 and our output was negative 9, x value, y value. So in part C, this is more elaborate. It's a weirder example. We want 2 times f of 3 plus g of negative 3. So since we're combining two functions, we're not really looking for just one y value. We're playing around with them. So 2 times whatever f of 3 is plus g of negative 3. Well, from this example, we know f of 3 is 4. And from this example, we know g of negative 3 is negative 9. So we have 8 plus negative 9, which equals negative 1. And this one really doesn't represent a coordinate because we were doing more with more than one function.